The operator watched it for 34 minutes. Standing there, 2,000 meters down, arms bent like elbows. He thought it was debris at first, discarded fishing line, some kind of industrial waste caught vertical in the current. The Gulf of Mexico is full of trash at depth, remnants of surface activity drifting down through the darkness, settling in positions that seem almost deliberate. He was wrong. This briefing addresses deep-sea encounter protocols. Operational designation Incident Report 7D. Subject classification Magnapinna species. Common reference the elbow walker. Depth range 1940 to 4735 meters. Lower bathypelagic zone. Haddle approaches. You are advised to maintain visual documentation at all times. Shell oil, Perdido Prospect Survey, April 2001. The ROV Magnum descended through the water column on standard geological assessment, seafloor stability mapping, 8-hour survey window, Atwater Valley Block 857. The pilot noted debris in frame at 14:23 hours. Standard procedure, approach and catalog, potential drilling hazard, the Magnum closed distance. At 14:26 hours, the debris rotated. 35 degrees, 6-second movement, deliberate, controlled. The pilot saw the mantle, 25 centimeters, small, translucent amber in the ROV lights, but the arms extended beyond camera frame limits. The Magnum backed to 8 meters to capture full specimen. Dual laser scaling measured arm span, 7.8 meters. The body was the size of a football. The arms could span a school bus. This ratio violates cephalopod mechanics. Standard squid anatomy maintains proportional appendage length. Magnapinna demonstrates 1600% body length ratio. Human equivalent, a 6-foot person with arms stretching 192 feet. The arms were 3 to 5 millimeters in diameter, thinner than human fingers, yet they held position at perfect 90-degree angles. 3 distinct bends per arm, geometric precise. Lead geologist Dr. Sarah Venkman filed initial report. We thought the thrusters had disturbed sediment causing illusion of movement. Then we saw the mantle. We realized we were looking at something alive. The specimen remained motionless for 47 minutes. No feeding behavior observed. No territorial display. No response to ROV proximity. At 15:14 hours, the pilot attempted contact approach. Distance 1.2 meters. The specimen rotated 180 degrees, 6 seconds, then resettled into standing position, facing opposite direction. Not one arm lifted from the seafloor during rotation. Protocol 7D was established following footage analysis. 23 minutes high-definition documentation, 340 still images, laser measurements confirmed. The specimen was sent to NOAA, to the Smithsonian. No database match existed. It became the holotype for a new genus, Magnapinna, Bigfin. But the name doesn't capture what makes it wrong. You need to understand the depth environment. 2,000 meters down, pressure reaches 200 atmospheres, 2850 psi. Water temperature holds at 2 to 4 degrees Celsius, just above freezing. Darkness is absolute. Your ROV lights penetrate 8 to 15 meters maximum. Beyond that, nothing. Black water extending in all directions. The seafloor is silty ooze, 15 to 40 centimeters deep. Every contact leaves an impression that persists for weeks. Current speed, 0.02 knots, nearly still water. It takes 6 hours for the water mass to move 100 meters. In this environment, every organism optimizes energy expenditure. Food is scarce. Metabolic resources are precious. Anglerfish wait motionless with lure extended. Minimal energy, maximum efficiency. Gulper eels have enormous mouths to ensure every strike counts. Giant squid possess massive eyes to detect prey from distance, minimizing search effort. Evolution favors conservation at depth. Magnapinna violates this principle. Incident review revealed small benthic organisms moving freely between the specimen's arms during entire observation period. Amphipods, copods, easy prey swimming within centimeters of those arms. The specimen did not react. It wasn't hunting. So what was it doing? NOAA's Okeanos Explorer, Deep Discoverer ROV, October 2007, Mid-Atlantic Ridge Oceanographer Fracture Zone, 2950 meters. Biodiversity Survey of Seamount Cluster, Standard Protocol. At 0947 hours, the Deep Discoverer encountered a Magnapinna specimen in a valley between two seamounts. Configuration, 6.2 meters arm span. The arms formed a perfect hexagonal cage pattern above the body. Geometry so precise the pilot initially suspected equipment malfunction. Straight lines, perfect angles. Nature doesn't generate this kind of symmetry. Crystals do. Human construction does. But not biology, not soft tissue, not arms that should curve and drift with current. Marine biologist Dr. James Chen requested close approach. Examination of sucker detail required. The ROV advanced to 0.8 meters. The specimen's chromatophores darkened uniformly over 72 seconds. Translucent amber shifted to deep red-brown. Calculated response, controlled pigment change. But it maintained position. At 10:31 hours, the ROV's manipulator arm extended. Objective, tissue sample collection from nearest tentacle tip. 7 seconds of approach. Manipulator closing distance. The specimen's eye tracked the arm throughout. Visible pupil dilation in frame-by-frame analysis. Orientation shift. It was watching. At 10:31 hours and 51 seconds, the specimen lifted a single arm. The one being approached. It bent the arm at a new 90-degree angle and repositioned the tip 40 centimeters away from the manipulator. Movement completed in 3.2 seconds. ROV pilot report. It moved exactly far enough to avoid contact, but not 1 centimeter more. Calculated, precise. 9 arms remained in original configuration. 1 arm held the new avoidance position. Observation continued 93 additional minutes. The specimen never reset the avoided arm. It maintained the new geometry, permanent adjustment, as if that 40 centimeter displacement was now the correct position. 0 tissue collected. Post-mission analysis documented first observed evasive behavior, but the analysis raised questions. The specimen watched the manipulator approach for 7 full seconds before moving. Response time to stimuli in Magnapinna, 8 to 12 seconds. This wasn't slowness. This was processing time. It calculated the exact moment intervention became necessary. It measured the approach vector, the manipulator speed, the closure rate. Then it moved the minimum distance required. Energy conservation, even in evasion. But energy conservation doesn't explain the standing posture. Maintaining muscle tension in 8-meter arms bent at 90 degrees requires immense force. No skeletal support exists in the arms, no rigid structure, pure muscle and collagen. Engineering analysis from MIT, 2022. Magnapinna arm configuration should require hydrostatic pressure system or skeletal reinforcement. Specimen possesses neither. Yet it holds position for hours, for days, for months. Serpent Project ROV Survey, September 2018, Great Australian Bight, Seduna Canyon System, 3380 meters. Deep Sea Mining Impact Assessment, route planned as 12-kilometer transect across canyon floor, standard documentation protocol. At 1922 hours, first Magnapinna specimen encountered. 5.9 meters arm span, standing posture photographed cataloged, ROV continued survey. At 1958 hours, 4.2 kilometers along route, second specimen encountered. Configuration, 6.4 meters arm span. Identical arm bending pattern to first specimen. Same number of joints, same angles, same hexagonal formation. The pilot noted the coincidence. Survey continued. At 20:34 hours, 8.1 kilometers along route, third specimen. Configuration identical to first two. At 21:11 hours, 11.8 kilometers along route, fourth specimen. Identical configuration. Marine biologist Dr. Patricia Okonkwo filed emergency protocol revision. 4 individuals across 12 kilometers, all holding the same position, same geometric arrangement. Probability analysis. Random identical arm configuration in organism with 10 independently controlled appendages and 3 to 7 joints, each calculates to 1 in 47 million. This wasn't coincidence. This was coordination. The ROV returned to specimen locations in reverse order. At 22:43 hours, position of fourth specimen at 11.8 kilometers, specimen still present, still in formation. At 23:09 hours, third specimen position at 8.1 kilometers, gone. Seafloor showed tripod contact depressions in sediment, 3 points where tentacle tips had pressed into the ooze, but no specimen, no directional disturbance patterns, no trails, no jets of water displacement indicating swimming direction. It had simply ceased contact with the seafloor and disappeared into 3380 meters of darkness. At 23:47 hours, second specimen position at 4.2 kilometers, still present, configuration maintained. At 00:15 hours, first specimen position, gone. 2 specimens vanished within a 2-hour window. Previous observations documented minimum standing duration of 4 to 6 hours, maximum observed 11 hours 34 minutes. But these vanished early. Sediment analysis revealed no swimming departure. The contact depressions showed vertical liftoff, straight up or straight down. Into water column or into seafloor, we cannot determine. What we know, they left in formation, coordinated withdrawal. 2 remained as markers while 2 departed. Like sentries rotating shifts. Audio distortion detected at depth. Hydrophone interference. Signal degradation beyond 3000 meters becomes standard. You lose clarity, you lose detail. But the visual data remains clear. The geometry remains perfect. 12 kilometers, 4 specimens, identical configuration, 2 vanish on schedule. This is not hunting behavior. This is not territorial defense. This is something else. Consider the deep ocean environment. Pressure at 3380 meters, 338 atmospheres, 4965, enough to crush most human-made equipment. Temperature, degrees Celsius, metabolic slowdown zone. Organisms at this depth operate at 12% the metabolic rate of surface species. Oxygen concentration, 3.2 milligrams per liter, 55% of surface levels, hypoxic conditions. Every organism adapts to conserve energy, minimize movement, reduce oxygen consumption. Magnapinna maintains standing posture for hours, days, months. Constant muscle tension, continuous energy expenditure. Why? Petrobras Deep Sea Monitoring Station, Campos Basin, Brazil, October 2022 deployment, camera retrieved October 2023. Permanent seafloor observatory, time-lapse imaging, 1 frame every 30 seconds, 12-month operational period. Depth, 4735 meters. Deepest documented Magnapinna sighting. Data review revealed specimen entry into frame December 18, 2022 at 03:15 hours. The specimen established standing position 4.2 meters from camera. Arm span 8.1 meters, longest documented appendage length. Configuration. 8 arms in standard cage formation, 2 specialized tentacles extended horizontally at 180-degree angles. Like a compass needle. The specimen remained in exact position until March 7, 2023, at 14:45 hours. Total duration, 78 days, 11 hours, 29 minutes, 30 seconds. 126,579 total frames captured. Specimen visible in 118,340 frames. Body rotation observed 34 times, always 15 to 45 degree increments. Chromatophore changes, 89 instances correlating with bioluminescent organisms passing through frame. Arm position changes, 0. Tentacle tips never lifted from seafloor during 78-day period. Research team calculated energy expenditure, maintaining muscle tension for 1,886 hours, estimated 23,000 calories. Potential prey passed within arm reach, 4,700 organisms, amphipods, copepods, small fish. Documented feeding events, 0. It stood there for 78 days without eating, without feeding, without hunting. Just standing. Holding position. At March 7th, 14:45 hours, the specimen rotated 90 degrees, standard 6-second movement. At 14:46 hours 30 seconds, it lifted all 10 appendages simultaneously. Arms remained in bent configuration. Locked angles maintained even during liftoff. At 14:47 hours, the specimen was gone. Vanished between frames, 30-second gap. No directional indicator, no swimming motion, no disturbance pattern. Frame analysis revealed detail missed during real-time observation. The compass needle tentacles had rotated during the 78-day standing period. December orientation, 45 degrees, 225 degrees, northeast, southwest alignment. March orientation, 110 degrees, 290 degrees, east-southeast, west-northwest alignment. Over 78 days of apparent stillness, it had slowly turned those 2 tentacles. Like the hands of a clock. Measuring something, tracking something. Aligned to something we cannot identify in the abyssal darkness. Time code error detected in recovered data. Recording timestamp unstable below 4500 meters. This is standard degradation, equipment limitation. But the visual record remains intact. 78 days, 1 position, 2 tentacles rotating like compass hands. What was it measuring? Tissue analysis presents additional complications. 23 arm fragments recovered across 40 years of deep-sea research. 0 complete bodies. The longest fragment, 1.4 meters of arm tissue, collected in 2012 via bottom trawl. Post-mortem analysis revealed unusual properties. Magnapinna tissue decomposes 89% faster than other deep-sea squids when brought to surface. 2019 fragment study showed protein composition 73% unknown collagen type. Collagen structure breaks down at temperatures above 6 degrees Celsius. It's thermally unstable, designed to exist only in near-freezing deep water. Surface retrieval procedure, specimen netted at depth, ascent rate standard, 2 meters per second. At 200 meters depth, water temperature reaches 25 degrees Celsius. Tissue begins liquefying. Within 12 hours of surface contact, the sample dissolves. This isn't decay, this is programmed dissolution. Theory 1, evolutionary anti-predation mechanism, prevents shallow predators from consuming tissue. Theory 2, pressure-dependent protein structure, collapses when atmospheric pressure drops below 150 atmospheres. Theory 3, deliberate biological security measure. Species evolved to prevent surface analysis of tissue composition. 2024 genetic analysis complicates understanding further. 2 mm tissue fragment. DNA sequencing revealed 34% sequences with no match to any known cephalopod, mollusk, or marine organism in genetic database. Closest match, 12% similarity to deep-sea bacteriophage, a virus that infects bacteria in hydrothermal vent systems. The question becomes, is Magnapinna entirely cephalopod? Or is it hybridized with something else at the genetic level? Something that exists in the volcanic zones of the deep ocean, in the chemistry of vent systems, in environments where our understanding of biology breaks down. All 12 documented Magnapinna sightings occurred within 400 kilometers of mid-ocean ridge systems. Volcanic zones, where Earth's crust is thinnest, where hydrothermal vents pump minerals and heat from the planet's mantle, where exotic chemistry creates environments unlike anywhere else on Earth. Descending through 1500 meters. Hull pressure nominal, sonar active. You're entering the zone where light dies completely, where bioluminescence becomes the only illumination. 60 to 80% of organisms at this depth produce their own light. It creates a galaxy effect in the darkness, points of blue-green glow drifting through the black water. Marine snow falls constantly, organic detritus from the surface, 10 to 40 particles per cubic meter drifting downward, accumulating on the seafloor as ooze. Everything that dies above eventually settles here. At 2000 meters, you're in the lower bathypelagic zone. Ambient sound, 20 to 30 decibels, quieter than a whisper. Your hydrophone picks up only the mechanical clicks of deep-sea shrimp. And sometimes something else. 2020 study documented the same individual filmed 14 days apart in identical position, plus or minus 3 meters. The specimen had not moved in 2 weeks. Still standing, still holding geometric arm configuration. Memory capability implies intelligence, planning, purpose. Most disturbing pattern across all observations, arm configurations never repeat between specimens. Each individual displays unique geometric pattern. 3 arms bent at 90 degrees, 4 at 180, 2 at 45, always different, always precise. If every specimen shows different configuration, it suggests each one is calibrated for different measurement at different location. Like weather stations, recording different variables, temperature, pressure, current direction, magnetic orientation. Biological instruments deployed to specific coordinates. But deployed by what? Evolution. Some deep-sea intelligence we haven't encountered? Or the squids themselves operating as distributed cognitive network? Neural distribution in Magnapinna, 60% of neurons located in arms. Standard squid, 40%. This represents distributed intelligence. Each arm possesses independent processing capability. 10 appendages, 10 semi-autonomous units coordinated by central mantle brain. Or perhaps not coordinated, perhaps collaborating. 2024 tissue imaging revealed crystalline structures embedded in muscle fiber. Geometric lattices, 0.4 to 0.8 micrometers in size, composition unknown, possibly providing structural reinforcement at molecular level. The question, are these crystals biological, grown by the squid? Or incorporated, absorbed from the environment? And if incorporated, from where in the deep ocean are they harvesting microscopic crystalline material? Hydrothermal vents produce mineral deposits, silicates, sulfides, metal oxides precipitating from superheated water. Some form crystalline structures at microscopic scale. If Magnapinna incorporates these crystals into tissue, it suggests proximity to vent systems, exposure to mineral-rich water, deliberate absorption. Building its own body from the geology of the deep ocean. Sonar ping echo detected, distance 40 meters. Object stationary, vertical profile consistent with biological contact. You approach slowly. ROV lights penetrate the darkness ahead. First, you see the arms, thin lines catching the light, translucent, amber-colored. Then you see the angles, the bends, the geometry that shouldn't exist in soft tissue. Then you see it standing there. Tips planted in the sediment, body elevated, arms forming cage structure above. You're at 10 meters distance, 5 meters, 3 meters. It doesn't move. You see the eye now, 4 to 6 centimeters in diameter, standard cephalopod structure, pupil dilating, adjusting to your lights. It's watching you. You're at 2 meters, 1 meter. Close enough to see through the translucent mantle, dark coils of digestive system visible inside, chromatophores rippling across the skin in slow waves. Close enough to see the suckers, thousands of them, microscopic, 0.8 to 1.2 millimeters in diameter, estimated 15,000 per arm. Amphipods swim between the arms, small benthic organisms moving freely through the cage, easy prey. The specimen doesn't react. Not hunting, not feeding. Just standing. You watch for 10 minutes, 20 minutes, 30 minutes. No movement, no feeding behavior, no territorial display. At 34 minutes, you begin to back away. At 34 minutes and 18 seconds, it rotates. 6-second movement. Body turns to face your direction of retreat. Arms never lift from seafloor. Now it's oriented toward you, eye tracking your ROV, watching you leave. You're at 10 meters, 15 meters, 20 meters. At 22 meters, it disappears into darkness beyond light range. But your depth finder shows no vertical movement. It hasn't swum away. It's exactly where you left it. Still standing, still watching. Days later, you review the footage frame by frame. You notice details missed in real time, chromatophore patterns rippling across the mantle every 45 seconds, like slow heartbeat, rhythmic, precise. The way its compass needle tentacles were oriented, magnetic north-south, exact alignment. Small benthic organisms avoided the area within its arm cage, even though no barrier existed, even though they could swim freely between the arms. They went around. Instinctive avoidance, as if they knew something you didn't. You check the coordinates. Flat abyssal plain, no geological features, no chemical seeps, no whale fall, nothing unusual about the location. Just empty ocean floor. So why there? Why that exact position? Why 78 days of standing? The horror is not the alien appearance, not the geometric arms, not even the standing duration. The horror is the efficiency paradox. This organism expends 23,000 calories maintaining posture while prey swims past untouched. It maintains muscle tension in 8-meter arms bent at precise angles despite no skeletal support, constant energy drain. It coordinates geometric formations across 12-kilometer distances with other individuals for unknown purpose. It possesses 60% neural distribution in arms, sophisticated intelligence requiring high metabolic cost. Yet it demonstrates no hunting behavior, no feeding, no reproduction observed, no territorial defense. This is an organism optimized for something other than survival. Humans build monuments. We expend resources creating structures that serve no immediate survival function: pyramids, telescopes, particle accelerators. We sacrifice efficiency for understanding, for measurement, for observation, for recording. What if Magnapinna is doing the same? What if those geometric arm formations, those compass needle orientations, Those 78-day standing periods at specific coordinates aren't hunting posture. What if they're measurement? What if they're not predators, but instruments? Biological instruments deployed to specific coordinates to collect data we can't fathom. The 2018 incident, 4 specimens across 12 kilometers, identical arm configuration. Not hunting pattern, triangulation. Not coincidence, standardization. Like scientific instruments calibrated to same settings. The refusal to feed despite available prey, not dysfunction. Focus. Like researcher ignoring hunger during critical observation period. We thought we were studying an animal. We might be looking at equipment. Deployed by what? Evolution, some deep-sea intelligence. The squids themselves operating as distributed cognitive network. Current data insufficient. Hypotheses suggest multiple possibilities, none conclusive. What we know, Magnapinna exists at depths where we've explored less than 0.01% of available habitat. All documented sightings occurred within 400 kilometers of mid-ocean ridge systems. Volcanic zones, hydrothermal vents, exotic chemistry. Genetic analysis shows 34% unknown DNA sequences. Tissue imaging reveals crystalline structures of unknown origin. Behavioral observation documents 78-day measurement activity. We have an organism with partially alien genetics, mineral-reinforced tissue, instrument-like behavior. Recent analysis suggests possibility we've drastically underestimated. What if Magnapinna didn't evolve in the ocean at all? What if it evolved in the crust, in subterranean seawater chambers we've never accessed? Caverns beneath the seafloor, connected to vent systems, spaces where water circulates through volcanic rock at extreme pressure and temperature. Environments where chemistry permits biology we can't imagine. And it only emerges to abyssal depths to perform these measurement behaviors. Then returns to hidden habitat beneath the seafloor, where no human instrument can follow. This would explain the 12 sightings across 40 years, not rare population, infrequent emergence. This would explain the tissue dissolution, not evolved for ocean water, evolved for different chemistry, different temperature, different pressure regime. Survives in ocean temporarily, long enough to complete measurement, then returns to subsurface habitat. This would explain the vanishing acts. No horizontal swimming, vertical descent through seafloor fissures we cannot detect with current sonar resolution. Down into the crust, into the volcanic systems beneath our mapped ocean floor. Segment corruption detected, recovery from backup log. This is standard at extreme depth. Data integrity compromises, recording artifacts accumulate. But the core observations remain valid. Magnapinna stands in the darkness for months, measuring, recording, oriented to magnetic north, tracking something with compass needle tentacles. Then it vanishes, no trace, no trail. Into 3 dimensions we cannot access, up into the water column beyond sonar range, or down into the earth beneath the ocean. What is it measuring in the abyss that requires 78 days of stillness? What data point is worth 23,000 calories of energy expenditure? If they're instruments, who deployed them? Are they still being deployed? Slow, deliberate placement rather than natural population growth would explain why we've only documented 12 specimens across 4 decades. Protocol 7D establishes observation guidelines. If you encounter Magnapinna during deep-sea operations, maintain minimum 5-meter distance, document position coordinates, record arm configuration, note orientation of specialized tentacles if visible. Do not attempt tissue collection. specimen will evade with calculated precision. Do not attempt prolonged contact. Response timeline suggests intelligence, patience, decision-making capacity. After 8 to 12 seconds of processing, it will choose whether you warrant acknowledgement. If it rotates to face you, you have crossed threshold. You are being measured. If specialized tentacles orient toward your position, you are being marked. Withdrawal protocol: back away slowly, maintain visual documentation, do not approach again. Return to surface, file encounter report, provide coordinates for database entry. Understand, you are advised that if you see one standing, your window to pass safely is before hour 4. After that, you're in the commitment zone. It won't flee even if threatened.
It's firing.
Because it's not there for you. It's there for something else, something specific, something we don't understand. If you see the same arm pattern twice in one survey, you haven't found two individuals. You've found two parts of a coordinated system. Note spacing, document geometry, report immediately. If compass needle tentacles point at your ROV, maintain position. Do not advance. You are being measured, assessed, recorded. The measurement will complete, then it will resume previous orientation. Unless you interfere, unless you force response. Movement means vulnerability for this species. When it's still, it's in control. If you make it move, you've disrupted something. Consequences unknown. There's a reason we've never recovered a complete body. 23 arm fragments across 40 years, 0 intact specimens. They're designed to erase themselves. Tissue dissolves 89% faster than other deep-sea squids, thermally unstable proteins, programmed dissolution. Someone doesn't want us studying them closely. When specimen disappears, it doesn't swim away. Depth finder shows no vertical movement in water column. Sediment shows no horizontal disturbance. It goes vertical, up or down, into layers we cannot access. There are dimensions to the ocean we haven't mapped, fissures in the seafloor connecting to subterranean water systems, vertical shafts dropping into the crust, spaces where volcanic heat meets seawater under pressures we cannot replicate. Magnapinna might be visiting from somewhere else, somewhere beneath, somewhere we've never reached. Emerging to take measurements, to record data, to mark positions, then returning to origin point in the planetary crust. This concludes Incident Report 7D. Supplemental documentation on deep crust biology theories is restricted. Clearance upgrade available through standard authorization protocols. Personnel are advised, the deep ocean keeps its methods silent. We've documented 12 individuals across 40 years of research. We've explored 0.01% of habitat where they operate. There could be thousands, standing in geometric formations across the abyssal plains, measuring, recording, coordinating. Building a map of something, a data set of something, for a purpose we cannot comprehend. And when the measurement is complete, they'll return to wherever they came from, taking the data with them, into the crust, into the dark, into spaces where pressure crushes our instruments and temperature melts our hull seals. Remember, if you see it, it has already seen you. That 8 to 12 second delay isn't slowness. It's processing time. It's deciding whether you matter. Whether your presence is significant enough to warrant acknowledgement. Most of the time, you don't matter. You're just another organism drifting through its measurement field, irrelevant to whatever it's recording. But sometimes you do matter. Sometimes it rotates to face you. Sometimes those compass needle tentacles point directly at your coordinates. And then you're part of the data. Part of whatever it's measuring. Recorded, marked, filed away in whatever passes for memory in an organism with 60% of its neurons distributed across 10 semi-autonomous arms. When it returns to the crust, it takes that recording with it. Your position, your depth, your time of encounter, added to a dataset spanning decades, centuries, millennia. We don't know what they're building. We don't know what they're measuring. We don't know where they take the data when they vanish into the seafloor. But they're still down there, standing in the darkness, arms bent at impossible angles, waiting, measuring, recording.